Okay, so good afternoon now. That's brilliant. Thank you very much for lending me your time. My name is Duncan Jones, and the presentation that I'm going to be doing here, if this works, is event sourcing and CQRS on Azure serverless functions. And what this basically is a way of building systems or partial systems on top of a purely serverless substrate, that's a good way of putting it. And so basically, the agenda for today, I'm going to go through the motivation, which is why you would do this in the first place. That's a good thing to start with, because if it doesn't apply to you, then that's probably best not to worry about the rest of it. Then an introduction to event sourcing. The system as a whole is based on event sourcing. So in order for me to explain the detail, to get into the weeds, I need to talk about event sourcing. It will be the most basic introduction. So don't report me to Greg if I get it wrong or anything like that. It really is just to get you familiar with it. Then a walkthrough example to show you how event sourcing works behind the scenes. Then I move on to notifications, which is how the different parts of the systems communicate with each other. And that's using EventGrid, Azure EventGrid, so I'll talk through that. A couple of things I'll do a little bit differently in this one is because it's not entirely interactive, so I will pause after each major thing. That's what that rather terrible graphic there is about. I'll pause after each major topic and leave a little bit of time for questions. And basically, if you have questions at any point, can you just put them in the chat window, and then when I reach a pause, you can stop me there. Oh, and the other thing I'm going to do is, again, because of the constraints of the internet connection, I'm going to leave all the show and tell stuff to the end. So anything that could potentially cause it to go horribly wrong, I'll leave that to the end. And basically, even when it does, you won't have missed too much, I hope. Okay, so a couple of caveats, though, before we begin. So caveats is that what I'm talking about here is it's for relatively small systems, and I haven't battle tested it. So don't go and put it into production in a nuclear power station tomorrow. That would be a mistake. And the other caveat is that what I'm talking about here is an experiment that I have done rather than a sort of definitive lecture. So, take that on board. If you think this is something you'd like to do, have a little play with the code, adapt it to your circumstances and so on. Okay, motivation. Why would we do this at all? So the promise of serverless, the promise certainly that you will see in the marketing brochures, is low cost and scaling to zero. So basically what you're looking for is systems where if you're not using it, or if your customer's not using it, even more importantly, it doesn't cost you very much money, or indeed it doesn't cost you any money at all. And the two sources of cost that we need to address in this is, the first one is fixed costs. So that's represented here by the immersion heater. If you're as old as me, you'll know that these things are never to be left on. And I'm even looking at that photo, I'm actually worrying now if I have left it on. But basically that explains fixed costs. So fixed costs are things that you have to leave on all the time for when your users come in. It has to be ready and warm. And the second one is over provisioning. So where you have to have excess resource put aside to deal with peaks of demand so you can ramp up quickly. And this is something that actually Azure Serverless Functions does very well. So I'm not going to add too much to that, but basically it is a motivation for using Azure Serverless Functions. So event sourcing. Event sourcing is a way of storing state or data. And in a traditional model-based system or a database or whatever, the way you do that is you store the current state of whatever your things are and you update them. What you do in event sourcing is you don't store the current state, but rather you store all the things that have happened to your entities over time as an event stream. And then you recreate the state by going through that history. And I think the best way I can really explain that is with this very hello world example. So imagine a bank account system, and you'll notice that event sourcing is nearly always demoed with bank accounts, but imagine a bank account system for my nephews and for their pocket money. So we start with this situation where there's no data at all in the system. Aidan comes along and he opens his account and he deposits $10. And you can see the events going across there. So basically, one event for opening the account, one event for depositing money. Similarly, then Margaret comes in. She does likewise. She deposits her $10. And then Fergal comes in, but on the way to the bank, he's actually managed to spend half his pocket money. So he only deposits the $5. And you can see the history building up for these entities. Aidan, having seen what Fergal has bought, decides he wants the same. So he withdraws $5. Then Margaret, seeing how this bank is being run, decides that she wants nothing more to do with it. So she withdraws all her money and closes her account. And you can see there that we're building a history of the events that have occurred to each, I'm going to call them entities, but you can give them any name you want, each uniquely identifiable thing. And that's fine getting the data into the system, but you also need to get the data out of the system. And you do that with something that's called a projection. So a projection is a very minimal piece of code, and it has two parts to it. The first part is, for each event, as it's going through the event stream, the question is asked, do I care about this event? And then the second part is, if I do care about the event, what am I doing with it? So if you look at this example here, the projection to get the current balance of the bank account. So we will start with opening the account. Do I care about that in terms of getting the current balance? I don't, so I skip over it. When you get to the deposit money, I do care about that event. So we're increasing the balance by the amount in the deposit money event. Then we get to the withdrawal money event. I do care about that, and we reduce the balance by that amount. So at this stage, what we're saying is we've got the actual state. And what I also do, sorry, I'll give you a couple of seconds to find the mute there. Okay, and what I also do whenever I run a projection is I return the as of event number that projection value is valid for. And I'll show you why that is later on, but this is an important thing to know about projections, that basically what we're saying is we get the state, but we also get the state as at a particular point in the projection, in the event stream. There are some rules that basically make event sourcing, that if you don't follow, make event sourcing very, 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 very difficult. So basic rules for event sourcing. The first one is that event streams are append only. So you can only add events to the end of an event stream. And that gives you an idea of the history in which they occurred. And the second really hard rule, which is why they're in bold, is that events are immutable. So you can't edit the data in an event. Now, there's a very obvious thing that should pop to everyone's mind there, which is what do you do when someone has made a mistake? And the answer is you have to do a reverse and rebook kind of event. So if you imagine that in our bank account example, rather than depositing $10, we had managed to withdraw $10, we have to deposit $10 to undo the withdrawal, and then we have to deposit another $10 so that we get back to where we're supposed to be. And that does mean that when you're designing an event source system, you want to think about events as having undoability. So you need to say, how am I going to get back to where I was if I've made a mistake? And then there's some guidelines, which I do think help a lot, but I'm not going to come around your house if you don't do this. The first one is that event names should be in the past tense, because you're communicating that this is a thing that has happened. So that's, for example, money withdrawn, not active withdrawal money, because that would be more of an active event. And the second one is that events are for one entity, so one thing that can be uniquely identified and which has a history. So first of the pauses, just to make sure that event sourcing hasn't caused angst and confusion. Are there any questions to this stage?
Nothing in the chat. Just one quick question there. You're saying that things are immutable there.
Yes.
Does that mean that, for instance, suppose, it's a bit of a, sort of not entirely technical question here, but GDPR, somebody comes along and says, please remove all my data from your system. So, you could delete it from the database, but then you've still got an event in there, presumably saying, data created, and another event saying data removed, but that data is still in the data created event.
Yes. So when I do this talk face to face, I usually have little toy crocodiles to give out as prizes. And that's the question that always gets the prize. So GDPR, obviously, when I say events are immutable, I mean in the standard business process. You can have another process that you either shred the GDPR content of the event, or you can have the GDPR content already held in an encrypted manner and throw away the keys or anything like that. So yeah, they are immutable, but with exceptional exceptions. Yes, exactly. I mean, and that is the same as if you had a database where there was no application way of altering data. You could still phone up the DBA at 3 o'clock in the morning and get it done. So yes, it is possible. The reason it's not done in actual normal business is that you rely on the state, and if the state was able to change, you'd have to rebuild it. You wouldn't be able to rely on it. So.
I'm just wondering, what happens when you try and rebuild with data that's actually changed?
Yeah. So I mean, you can do it. You run the projection again, and you do that. But as a general rule, it's best to go forwards.
Okay.
Okay. So the walkthrough example, which I hope will make this more obvious, and will also show you some of the pitfalls of event sourcing on an Azure Functions system. There's a URL there if you want to play along at home. It just brings up a Blazor front end, which you can enter transactions in and whatever you want to do. It's a very, very simple banking example, so just an extension of what I talked through in the first part. The Blazor is not particularly pretty because I'm not a front end person, so I just sort of hacked it together. But with that in mind, let me talk you through the way it goes. So our first command is to open a new account, and the constraints that we've been given are each account number must be unique. So I'm not allowed to open an account if that number has already been used, and I'm passing in the account number as a parameter here. I'm imagining it that way around. And we have some additional things that we can add in. So we can say you can open an account with an initial deposit, and also when you open an account, you can also pass in the beneficiary name. I've made both of those optional. If you do work in banking, remember that they are not optional because the lawyers will come after you. But that's basically what it's saying. But this introduces us to the villain of the piece, the concurrency crocodile. So this is essentially a kind of defect that can occur, nearly only really occurs in production, and it's where two functions are trying to do the same thing at the same time. So my bit where I'm saying each account number must be unique. What happens if I am running two or more Azure functions that have got the same account number when they're trying to create them? And let's look at how we do that. So start with the Azure function definition. And as you can see, basically standard HTTP triggered function. And the only difference is at the bottom, we've got an event stream that I'm creating. And that takes the account number passed in via the HTTP route and turns it into our event stream unique identifier. And three parts to this: there's domain, entity name, and instance. So that's basically my unique key of my event stream. And that allows us to have systems with different domains in, different entity types or whatever, and basically still keep everything reasonably organized. So step 2. So I'm opening my new account. The first thing is, does the bank account number already exist? If it does, I'm just returning a forbidden, so you're not allowed to do that. The second step is, having got past that, we are going to put a created event on the event stream. Now the created event is also going to create the event stream. So that will be our first event. And what you'll see here is we have two checks. So the first one is the business level one of just saying the account number also already exists. But the second one is we also include a constraint when we're appending the event, the account opened event, just saying that this event stream must be new, and it will fail with it will throw an exception if the event stream already exists. And that's basically our way of preventing the concurrency crocodile from giving us a good bite there. Having done that, we have two additional parts that we can do. So there are two optional parameters that we passed in. So if we've pass in an opening balance, we put that in a money deposited event and append that to the end of the bank account events event stream. And similarly, if we have given the beneficiary name, we create a beneficiary set event. So this is to show you how one command can actually lead to more than one event. And then how does it get stored? So it goes into a table. This is a standard Azure table. I think they've now moved into Cosmos DB, but this is just basically a straightforward NoSQL table. And I'm using the unique identifier of my account as the partition key, and the row key is basically the number of the event. So that's an incremental sequence number. The row 0 gives you information about the instance. So that's basically saying what domain, entity type, instance key, and so on it is, and also gives you the last sequence number used. And then as you go through each event, it basically appends the event type onto a row with the event type, and then whatever data pertains to that particular type of event. So you can see here we've got an account opened, money deposited, etc. So that's basically the life cycle of a single account. Making a deposit, we've got the same rule that says a target account must exist. We don't have a concurrency crocodile thing here because, if two people make the deposits at the same time, that doesn't matter to us. Parameters, we have a deposit amount, so how much is going to be deposited, and then optionally you can put in some text to say where the deposit came from. And again, the function body is basically, does the bank account exist? If it doesn't, throw a forbidden HTTP response. But if it does, we're creating the money deposited data, which is our event, and simply appending it towards actually on the end of the event stream. So that's that one. Getting the balance. So this is about getting the data back out again. So what we're going to do is we're going to run a projection. And obviously, in order to get the balance, we need the account number itself. So the account number from which the balance, that must exist. And the second parameter we can pass in is an as of date. And this demonstrates one of the sort of quite powerful properties of event sourcing, which is that you can run a projection to any point in the event stream. So as well as asking what the state is now, it's quite straightforward to ask what the state was last year, yesterday, etc. So you can pass in the parameter, the as of date for the balance to get, and it will just run the projection up to that point. So let us look at our projection. So this is just the HTTP trigger again. This time it's a get because we want to get data, and we're just passing in the bank account and account number, but as well as that, we're passing in the name of the projection. So we're saying this particular projection is the one I want to run. And the reason being that this allows you to have different projections over the same entity. So you might have one that says your balance, you might have one that says last 10 transactions or whatever, and they can all be independently run. Yeah, type of projection to run. And the balance projection, as I said, it's just got two parts to it. So the first part is, do I care about this event? And the way I'm indicating that here is with the I handle event type interface. So everything that has got that in it in the projection class, it does process. Anything that hasn't got one of those, it just skips over. And then obviously, what am I doing with the event when I get it? So with the money deposited event, what I'm doing is I'm increasing the balance, and with the money withdrawn, I'm decreasing the balance. And that basically, we take this bit of code, we run it through our event stream to whichever point we want, and that will return the balance. And basically, this is how we're doing it. So we pass in the as of date as a parameter, we run the projection to that as of date, and then we just return the result in a nice friendly bit of text. And as I mentioned earlier, as well as returning the value, the current balance, it also returns the sequence number as of which that balance was valid, which is, as I say, is an important thing you're doing. If you end up doing event sourcing, I would definitely recommend that every time you run a projection, you also give that bit of data back. And so that's what it looks like in the front end. Well, in my version of the front end. Obviously, this will be wrapped in something much nicer if you were going to give it to production. Okay, the third bit to illustrate how things get a little bit harder. So making a withdrawal. So we have a target account must exist. We already know how to do that. But the second part is that the balance must be greater than or equal to the withdrawal amount. So you can't, in this version of the bank account, you can't go withdrawn. And this introduces yet another concurrency crocodile, because while I'm making this withdrawal and performing these tests, you could also be either doing another withdrawal, or you could be doing a, well, all sorts of different transactions. So I need to know whether I can rely on the balance that I have got before I actually make the withdrawal. And obviously, withdrawal amount is a parameter passed in. So for this one, we're going to have two parameters. We have our event stream, of which we're going to append the events if everything's successful, but we also need to run the balance projection. So we run the balance projection to tell us whether we're able to make the withdrawal. And the way that that happens is we run the balance projection first. If the current balance is greater than or equal to the amount to be withdrawn, then we can go ahead and make the withdrawal. So we put our withdrawal event together and we append it. But we also have this parameter here, the current sequence number, and that's passed in when you're appending an event, or optionally passed in. If you pass it in, then if that isn't the current top sequence number of the event stream when it goes ahead and appends the event, it actually throws an exception. So this is to prevent you getting into a concurrency situation. How you handle that exception is entirely up to you. You need to have a little business discussion and say, what do we do? Can we retry it? Do we put it on a failure queue, etc.? But basically, at this level, what we're saying is we can't allow the withdrawal to go in if it would result in the balance being overdrawn. And if we aren't on the current sequence number when we've run our projection, we don't know for a fact that our balance that we have used in this if clause is still valid. And this is how it looks. So what we're saying is when you run it and you don't have sufficient funds, it's going to return a thing in there saying your account number did not have sufficient funds. Hey, another pause for any questions at that point. Nope.
Nope, doesn't seem to be any questions. Obviously doing a
job. Well, either I am or the crocodiles are. Okay, notifications. So we have built a system so far that allows you to get data into it and relatively safely get data into it. I always say relatively because if you say safely, it'll go wrong and then you'll have made a promise you can't keep. But that's only half the purpose of our system. We also need to have the fact that things have occurred in one part of a system passed over to other parts of the system to create other, to kick off other functionality. And I mean, a good example of that might be, well, if we have a new bank account created, we might want the post room to send them a welcome pack. So we get a notification from that the new entity was created, and we use it to basically put together the next step. And I have two forms of notifications here coming off each event stream. The first one is a new entity was created. So in our example, the bank account, and that just passes as parameters the domain, the entity type, and the instance, so the unique key of whatever was created. And the second one is whenever an event is appended to an event stream, it raises a notification with the domain, entity type, and also event type. So if the event type was money withdrawn, your notification would be bank.account.money withdrawn. It also sends the sequence number, as we were talking about before. That's always important if you are relying on state downstream. And the event details payload can be included. So with our withdrawal event, you would also include the amount withdrawn and so on. And this gives you a sort of, it's very analogous to a change feed in a database. So it's a change feed for event streams. In addition, whenever a projection is run and completes, I also send out a notification that the projection has run and completed. And the idea behind this is to reduce the amount of work done getting state. Really cares about reference data or whatever, your system that's updating the reference data, sorry, I've got a bad network quality there. Your system that's updating the data may, may want to know about these notifications, but it doesn't need to keep asking for projections itself. Okay, so that's all done through Event Grid, and I send out the notifications to Event Grid as custom topics and custom events. And then Event Grid allows you to pub/sub situation. It allows you to send that on to other parts of your system, which can be written in many different ways. You can have Azure functions or logic apps or automation or webhooks. I use Azure functions, but that's personal preference. You can, as I say, you can have it react to change in any way. There are a couple of caveats first that you need to be aware of. So Event Grid is an always on system. So there is a continuous cost to running Event Grid. It's a shared system, so it's not a particularly high continuous cost, but it is something that you are, you do need to be aware of. And the second one is that Event Grid's promise is at least once delivery. So every event will be delivered at least once. What that means practically is that it will be delivered at least once, sometimes twice, occasionally 3 times, and so on. So what that means is your receiving systems have to be able to deal with the fact that they may have received the same information twice. And that again is another reason why I always put the sequence number in when I'm doing a projection. You need your receiving systems to be able to say, okay, I've already received this information, I don't need to act on it this time. And you would code it that way. Event Grid allows you to filter those messages on their way to the output. So what we would do is, using the event types there, we'd say, okay, some functionality cares about interest being paid, so that will be filtered by bank.account.interest_paid. That's our event type, and so on. And some functionality might care about a new bank account being created, so that would look for event type of new entity with the prefix filter being bank account. So we're saying a new bank account was created. You can filter by the content of the event message as well. And if you want to do, but it's not my preference. I prefer to have a bit more of a visible system. So I name my Event Grid filters on whatever has happened, and I have them going by event type if possible. And what does it look like in the message? So we have got our, this is the message content received by whatever you have got hooked up as a subscriber. You have your notification unique identifier. You have the details of what the event happened to. So we've got domain name, entity type, and instance key, and also the sequence number. And in addition to that, you've got the actual data. So the current balance was 5048.28. The sequence number was 118. Don't worry about snapshots. That's for an advanced version, which I have not written yet. Okay, and then how would you hook everything together? So in serverless, the concept of applications and domains is a little bit nebulous, because basically you would create your functions in whatever account, whatever application you want, and organize them how you would. They will be launched from each other and whatever. So it's a little bit tenuous. This here is an overview that is a logical overview. Then you might not deploy things this way, but this is how you might think about them. And essentially, we have our 3 domains with commands and queries going into them from the outside world. And then when changes occur to them, they send notifications which other ones can pick up on. So as I mentioned earlier, if your bank account, if you have a withdrawal, that might notify another thing in the branch thing to do something behind the scenes, or if a new product is launched, it might alter your what's available in the branch, and so on. So systems can listen to each other in that manner. So handling a command coming in from the outside world. So we pass in the command name, parameters, and context. So context is user ID, IP address, all the sort of where did this account come from, and that goes into Event Grid. An event grid then fires up a durable function orchestration. So this is Azure durable functions. And behind the scenes, that then creates its own event stream. Now, a bit of disambiguity here. I mean the event stream from my system, not the event stream that durable functions itself uses, because behind the scenes, durable functions also use event sourcing. But so what I'm talking about is a unique event stream for this command. And validations are performed as a durable functions activity. So whatever, is whatever was passed in valid? Is the command well formed, and are the parameters sensible, and so on. And if that is all good, that's pasted. That's the written back to the event stream. And then the actual command is executed. So the events are appended to the underlying event streams of the thing that gets changed. So if you imagine here, we're doing a withdrawal, for example, you do your withdrawal validations, and then you append the withdrawal amounts on whichever event streams are being updated. And as I say, that's all through event grid. So how does it look? We are kicking off a durable function context. So that's saying, OK, I want to perform this action. That then kicks off the activities for each action in turn. So what I'm showing in this example is actually applying interest for all the accounts. So this is to show how one command can actually act on many different underlying event streams. And the way I'm doing that is you kick off the command, and then you do a fan out orchestration that says for each account number, perform the job of applying the interest. The fan out sub orchestration just works on one event stream. So basically we're saying this is going to be kicked off by durable functions for every single event stream that I want updating. And then on each one, this little sub orchestration will work. It will finish and it'll go back to the main orchestration when it's complete. A query is done very much the same way. The only difference with the query is that I also allow you to pass in return addresses. So return addresses are where do you want the answer to your query delivered. So you start with the query name, parameters, etc. And you also have to add on either a webhook or an address or email address or whatever, however you're returning the data. And behind the scenes, again, that kicks off a event stream that is unique to this query. So this particular query has its own event stream, so it can track progress.
Quick question just come in there, Duncan, if you...
Yeah, fire ahead.
Somebody's wondering how do you get a unique sequence number? Do you use some sort of locking mechanism?
I do, yes. So the unique sequence number comes from the bottom, what would you call it, the index record. So the index record, when you update that, it has a E tag to say nobody else has attempted to update it at the same time. And the way you generate the next sequence number is you say, OK, what is the current sequence number? Update it and save it. And if that update and save succeeds, you're allowed to use that sequence number. So yeah, it's an auto increment that has been implemented by myself, and it's not necessarily brilliant, but it's the only way I was able to do it on Azure tables. I wouldn't recommend trying to run a query to get the highest one. I started off doing that, and that is not performant at all. Yeah, so don't do that.
Expensive, yeah.
Okay.
Okay, carry on.
All right, no problem. So, okay, so we've done our query validations. We're saying, is it possible to run this query? Always worth doing that before you run the query, because you save yourself a bit of processing time. And then we run all the projections that are needed to fulfill the query. So if you remember right back to the balance projection in episode 1, if you remember back to that, if we wanted to get the balance of a number of accounts, you pass that in and then you run those projections in parallel using the same fan out methodology. And then when the answers come back, you can then do a collate state. So it's not a million miles away from MapReduce in concept, but basically what we're saying is if you need to get data from many things, many entities, you can run that in parallel and have it all come back together again to give you your answer. And then obviously your return addresses, you return the result to everyone who is interested in it. So this also allows you to do things like logging and things like that, where you say, okay, whenever a query is created, also add a return address of the logging system. And the way that works is we kick up our, this is our query event stream. We have our query, and then basically we request the projections and we put them on that as an event. So let's say we need 10 balance projections. We put each request for that balance projection onto our event stream, and then we're able to run them in parallel using this query orchestrator. So we're basically saying for every projection that hasn't completed yet, go ahead and start it running. And then this is done as an Azure durable function task, and then it will return back to the parent orchestration when it's complete. Okay, code and architecture recap, just to pause there and see where we've got to. So the system hangs together with event grid function triggers. The system is based on event sourcing with Azure function. And basically the queries and commands are done with durable functions. And the main way that works is to have fan out going on behind the scenes. And everything, the data for everything is stored in event streams and projections. There's a GitHub there that has all the source code to this. And I think reasonably well commented, but certainly if you have any questions on it, get back to me on that GitHub and I will clean it up, but it is there.
That's a quick question there.
Oh yeah.
Oh right, is that the end already?
Well, no, go for a Q&A.
No, just while you're on the one that said architecture there, we've actually just had a question in about that. It says, solution looks great, has a lot of moving messages, event grid, message types, event stream topics, notifications, and so on. It says, as an application architect, you clearly plan before you code. Can you talk about how you'd architect, plan, and document your solution for what's a serverless microarchitecture, like tools you use, for example?
Yeah, okay. Quite an assumption about my professionalism there, but anyway, okay. Yeah, so design is really important with this, actually up front, so before you start coding, because what happens is when you've written even a serverless function, when you've written it, it's really hard to go, well, that was wrong, and delete it. You know, you become attached to it. So the more you can do on paper, on whiteboards, in screaming arguments, in boardrooms or whatever, the better. And the best technique for finding your events and finding your how everything hangs together is something called event storming, which is a sort of, you get an enormous sheet of paper and you basically all start putting up events and things, and then you basically collaboratively work out what belongs where and what causes what and so on. And I would do quite a few iterations of that before you get down to coding it. But in terms of tooling, there isn't great tooling for this, which is the bottom line. There isn't great tooling for visualizing a serverless system, and there isn't really great tooling for designing it, because as you can see, I've just got functions coded there. I'm giving them the function name, but it could be, I could have given it the wrong name, and then then I won't know that that's happened. I won't know that I'm calling the wrong function or whatever.
Yeah, and I've seen event storming. The tooling has literally been a wall and sticky notes.
That's precisely how I do it. Yeah. So you go to IKEA, which is the cheapest place you can buy these things. You get the really long roll of paper, and you stick it up on the boardroom, and basically start putting the events on. And someone comes in, or you get all the experts you can in, and you get them to disagree with you. And you move everything around, and then you go for lunch, and you come back and you go, yeah, we were completely wrong, and you do it again, and do it several times, and you will end up with something approaching the correct thing. But you can change things after the fact as well. So one of the things that I would recommend for event source system is actually event versioning. So if you have a situation where you have created an event and it's been in production for a little while, and you realize that you have got it wrong, you've maybe got too few parameters, or your parameters are wrong, or whatever, you can create a version 1, version 2, version 3, etc. And then you just need to create an anti-corruption layer bit of code to turn a version 1 into a version 2 if your projection is looking for a version 2. So it is possible to do in the same way as you would do that if you got a database design wrong.
And there's another question here. What are the best practices for tracing the events?
Oh, okay, that's a good point. I'm going to Alt tab out of this thing here, and so if you forgive me half a second, let me just show you. So this is the notifications on Azure. So when an event occurs, these are my notifications. So you can see them actually, how many. So we've had 3 in the last hour or so. If I span it out to 12 hours and so on, you can see what's happening there. But if you want to drill into it, I would recommend, having your functions go into application insights and, use that to do your detailed work. Now,
put it into a structured log query sort of thing.
Yeah, exactly. So because everything that happens is an Azure function, and that Azure function can be hooked up to application insights, you can look into, let's say the bank account opened command. You can look into that and say, what parameters were passed in, what was the state, and so on. You can actually see that in insights. So that's how that would work. And then because you've got filtering going on, you can actually drill down into this. So if you, for example, wanted to put together one of those dashboards that my management are so keen on, you could say, okay, I'm just going to filter by, let's say, account opened, and I can show you a lovely little graph of how many accounts have been opened in the last 30 days or whatever, without adding any more code and without using up any more of my time.
Okay, that's okay. The questions for now.
Okay, that's brilliant. So let me quickly show you the bit that can go wrong, because I'm going to have to connect to the back end here. So I have got Postman, developer's friend. So we'll start with this account does not exist. So I've called it GA 2020 test 01. That's my account number there. Start with that. If I send the message, fire enough, and it comes back with this account is not yet created. So I was not able to retrieve a balance for it. So I will go in and open an account. So you can see here, these are my parameters that I'm passing in, just to show you that this is actually real and live. Let's put 1901 as our opening balance and name Duncan Jones Azure. Well, just to prove that I'm not cheating you here, because you're not paying customers, so you don't have to be cheated. Okay, so I send that off, and it says it has created it. If I now go back to my Azure portal and look in the Storage Explorer, so that's my unique key that I passed in. That was my account number. If I run the query now, we have our events there. So you see the first row key, all zeros, that's my index thing, and that says there are 3, the last sequence number is 3. So there are 3 events that have occurred to this thing. The things that have occurred, that's event type, was account opened, money deposited, and designated beneficiary set. So you can see there, if you want to see the money deposited, you can go across here, and you can see that 1901 was deposited. Oh, bring up all the details there, the date and time it happened, and so on. So it exists, and data has gone into it. We can go back to get our balance, send that. It does exist, and it has a balance of 1901. I'll go ahead and deposit some money. Let's look at the body. Okay. Send that. And again, it's saying the amount was deposited. Let's go quickly back to the portal and see if I run this query again. Okay, so you can see the deposit has occurred there. And then let's try an outrageously large withdrawal and make sure that it doesn't allow us to do that. So outrageously large withdrawal, let's go to our body, and we are going to send that, and it's going to say it doesn't have sufficient funds. The current balance is 4021, and therefore it didn't actually append the event. And I'll go back and just prove that for myself as much as for anyone else, because that was a bit Okay, so it hasn't put the withdrawal amount on. And there's a whole bunch of other stuff that I've done to do with accruing interest and all that kind of stuff as well. But this will give you an idea of what's going on. I'll actually withdraw a sensible amount and just make sure it does work. Okay, so now it is, and it gives you the new balance and so on. And if I just go back to there, run the query again, and you can see those are the things. Now, when I'm doing a multi-step command, the multi-step command also has an event stream behind it. So for each command that has ever run, I can have this kind of detail that says, okay, the command came in, these were the parameters that were assigned to it. This was the result of the validation. These things were kicked off and so on. So it does allow you to have quite a deep dive into the processing part of your application as well. And I'll just show you as well that all of that messing should have created some events. If I go back to 1 hour. Yeah, so us doing that work there has triggered a bunch of event grid messages as well. I would imagine the two appends, the create and the projection. So
Duncan, we've got another question in the chat.
Go ahead, yeah.
Is there a reason that you've not mentioned read models?
Time constraint. So
Can't come at all.
No. So when I did the query, so the query, you put in a bunch of targets, return addresses, basically. That could be your user interface if you want the information straight back, but it could also be a downstream data system, which would be a read model. So that could be either a straightforward database, a data warehouse. Flat files is very good, and my favorite read model of all, which is pre-built HTML, because that is really fast at loading. So yeah, you can build that with this. I don't have any preference whatsoever where the data from queries goes, but I would call most of those read models, apart from the live interactive version. And the other thing is, of course, with Azure Functions, you can kick them off on a schedule, or you could have a different thing causing the event grid to kick it off or whatever. So it doesn't have to be a user performing the query. It could also be a nightly batch, or it could be, when we realize X number of things have happened, we kick off a query or whatever. So you can do it that way.
Well, we're paused. There's another question in here, also mentioning read models. For the withdrawal command, are you recalculating the current state of the account, so fully rerunning the projection, or are you relying on a saved read model somewhere when you're performing the business logic relating to the withdrawal amount?
I am relying on the calculated amount, so I run the projection every time. The projection code. The projection code does allow for snapshots. So that's what that earlier thing where I said support snapshots and it was false. For projections that it makes sense to have a snapshot, so a balance would be a very good example. Your balance as at event number 4 is always going to be the same. So it's perfectly legitimate to save that somewhere and then reload that rather than running it through the full history. But for this kind of system, it is relatively fast until you get history of 3,000, 4,000, 5,000 events. It's kind of designed for wide and shallow data systems. So basically, you've got many entities, but each of those entities has got a relatively short lifespan. So bank accounts, maybe not a great example, but commands and queries and whatever, you might have 20 steps on a standard command handler or command saga or whatever you want to call it. So it is not going to be slow to recreate the whole thing.
And apparently you preempted his next question.
Oh, okay. I mean, I can prove myself wrong. So this one has got a decent number of events. So this is, as I was saying, this is my horrendous UI. But what we're basically saying is if I want to run this, get the balance for as of today, fire that off. It is going to take a couple of seconds. It took 0.92 seconds to execute that, and it's 1,390 events. It basically goes reasonably linearly. So, you know, it would take, if you had 10 times as many, it would take 10 seconds to return the result. Obviously, if you have an interactive system, like if this was your actual bank account, you would return a cached version of the page as of last night that you would generate automatically, and then behind the scenes you would update any new events and present them in a slightly different thing, saying, and then you call them something like uncleared or whatever you want to do. But basically, you hide the processing time from the user. And this is what my bank, actually, Bank of Ireland, actually do. I know this because I can sometimes see the same transaction in both the cached version from last night and the to be processed version today. So, you know, they're obviously got a bit of eventual consistency going on.
Right. That's it for questions at the moment.
Okie dokie. So I will post the GitHub and the URL of this little play bank account version. And yeah, thank you very much for lending me your time. Brilliant.
Thank you. Just one question from my point of view, just kind of trailing my own talk later on. Do you ever feel the urge to sort of break out of Azure Functions? Is there anything, you ever think, well, actually, this doesn't fit the serverless model?
Yes. So, yeah, I wouldn't really design an entire system with either serverless or with event sourcing. I mean, I would consider it to be a partial, to a partial solution. So there are going to be bits that it doesn't make sense to do. And what I would say is anything to do with reporting, what if analysis, all that kind of stuff that people do using Excel, or if you're as old as me, even Crystal reports. That kind of stuff. Yeah. Oh my God, I've got the scars. But that kind of stuff probably isn't serverless. But I will say, especially with durable functions, now that durable functions is there aren't that many things. I'm surprised how few things I get to do and go, well, that really doesn't suit, and I'm going to have to either have a physical server or spin up a VM for this or whatever. But that may be my business domain rather than a sort of general thing for everyone. Oh, and the other thing that people do get interested in is the cost. Let me see if I've got the cost here. So this is a example system that has 20,000 bank accounts in, and each bank account. So there's a bunch of random things happen to try and do withdrawals and deposits and whatever. So 20,000, they all have interest accrued daily, paid monthly. They have up 10 or so accounts, transactions per day, and so on. And it comes in at about €1 a day. And the other thing about that is, if you drill down into that, most of that cost is actually application insights rather than the thing itself. I can't live without application insights, but it is true to say that it's not 3/4 of that money. No, it's not. But 3/4 of that money is actually the debugging and tracing and everything else.
Yeah. And I know Microsoft try and push Cosmos as an events sourcing solution on the grounds that you can use it as your event storage and your event source, if you sort of by using the change feed off the collection in Cosmos. Have you done that? Because I would imagine that cost of that would probably push you up a bit.
I haven't, but I do know people who have working for Jet, Jet.com.
Oh yeah, the Walmart.
Yes, exactly. So that's all Cosmos DB backed and event source, and it's done in F#. As far as I know, there's quite a lot of their stuff open source. So if that's the where you're going down, that it is definitely is doable, and it's obviously doable at considerable scale. So, but yes, the reason I'm doing this is because this is a thing to scale to zero. So it's for things where maybe for 3 months of the year it's intensely used and then it's not used, maybe every other day is used or something like that. Or, if it was an event, so let's say you had a mini marathon and the registrations come pouring in the week before, and then people run the event and then nothing happens or whatever. It's really about the very rapid up and down of demand. So as long as if you've got something where you do want it to scale to as near to zero as possible, then this is a good solution for that.
Perfect.
Awesome. Thank you so much for that session. Lots of people in the chat saying thank you. Great talk. So that's good.
Thank you very much.